Hello everyone, welcome to my channel Direct Approach. In today's lesson we are going to discuss the hexadecimal to binary conversion and vice versa. So in the first column we have the decimal numbers, the second column we have the binary numbers, and the third column we have the hexadecimal numbers. So these columns are very important and maybe should be memorized. In my case, for my university, I memorized them in order to make things simpler. So we will start by looking at the binary numbers. In order to represent the number 1, we have to include 3 zeros and then a 1. In order to represent the number 2, we have to include 2 zeros, 1, and another 0. 3, 0, 0, 1, 1. Number 4, 0, 1, 0, 0. Number 5 is 0, 1, 0, 1. So how do we represent these numbers? These numbers are represented numbers can basically be represented as powers of 2. So in this example, I'm going to look at, for this moment, the number 5. The number 5 is basically represented as 2 to the power of 0 plus 2 to the power of 2, which is equal to 5. How do we do that? So looking back at the binary numbers, you basically have to memorize the numbers from 1 till 16. From 0 till 16, sorry. So the binary number of 0 is 0000. The number 1 is 0001. The number 2 is 0010. So we basically just keep on adding ones to it. It basically looks a bit confusing, but you have to maybe sometimes pause the video in order to understand the binary numbers, since they can be sometimes a bit tricky. But for the number 15, I will do this example for you once again, or to represent it and make it easier for you. The number 15 is basically a composition of two to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3, which is equal to 15. I know, guys, it looks really confusing. I had the same trouble and the same issues all along, but looking at the videos and trying to understand it myself, I'm trying to make these videos in order to make it simpler. Anyway, so 2 to the power of 0, which is the first place, which is 1. And then we have the number 2 to the power of 1, which is another 1. And then 2 to the power of 2, which is the third place, which is another 1. And then we have another 3, which is another 1. So looking at these, this is basically the 0th place, the first place, the second place, the third place. So here we look at 0, 1, 2, and 3. So another example, I'm going to look at the number 10, since it may be easier for you to understand. The number 10 is in binary 1010. So to convert this number, which we assume we don't know, is 2 to the power of 0, which is 0 plus 2 to the power of 1, which, since this is the first place and this is the 0th place, and then we add plus 0, since the third place is a 0 and we don't have a 1, and then we add 2 to the power of 3, which is equal to 10 in total. So now we're going to look at the binary to hexadecimal numbers. We will assume a very big number, which is in binary 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 1, 0, 0, 0. So this is the binary number that we are going to try and convert to a hexadecimal number. In order to convert it to a hexadecimal number, we have to basically break it down into chunks of 4. That's why I have written them directly like that. These chunks of 4 are a very easy and simple method I learned in order to represent the hexadecimal number much easier. So what we have just learned here in the examples above number 15 and number 10 is the conversion from decimal to binary number. So in order to convert from the binary to a hexadecimal number, we have to represent these numbers in a decimal number. So in this case, this is represented as 2 to the power of 1 plus 2 to the power of 2, which is equal to 6. And since this is a 6, we have to look at the table above. The number 6 is also the number 6 in decimal, so we can just write the number 6. For these 4 digits, we have to add the ones, which is 2 to the power of 3 plus 2 to the power of 2 plus 2 to the power of 1, which is equal to 14. Now the number 14, looking back at the table, which is in hexadecimal, which is an E, as can be seen here. Decimal, binary, the binary number is 1110, which is an E. So we just place an E below. So I'm not going to do the rest in front of you, but looking at the number 0111, looking at the table, 0111 is a 7, as can be seen in this column. So we're going to write the number 7. Moreover, we're going to look at these 4 digits, which is a 1100. 1100 is a C, which is 12 in decimal, which is the number C. 1111 is an F. So this number 1111 is an F, which is very easily known since just looking at the table, and you just have to memorize basically this column or these 3 rows. These 3 columns. And then the number, this 1000 is represented as the number 8, as can be seen. So this is the number 8. And there you go. Now we have just converted the binary into a hex. It's really simple, guys. You just have to look over the video and understand the concept of the binary to a hexadecimal to decimal conversion, since this is very essential in order to be able to simply switch between these conversions. So the hex number to a binary number. So the binary number that we are going to look at is cafe. Since this is an example the professor used to give us a lot in the exams. Cafe is coffee in English. So it's actually really simple. Once again, you have to break down the words since it's basically divided up into chunks, cafe. So we take the first letter, C. The letter C is represented, looking back at the table, C is represented as 1100, which is the number 12. Which is the number 12 in decimal, and in binary it's 1100. The letter A is represented as 1010. The letter F, so guys look, we're just breaking down these few words into binary. The letter F is represented as 1111. This is very easy to memorize, since the letter F, you just have to memorize 4 ones, and that's why we always represent the numbers, or mostly represent the numbers as 4 numbers, since the letter F has 4 ones in it. The letter E is in binary, it's 1110. So looking back up, the letter E here is 1110. So thank you, guys. You can pause the video now if you need to look or take a look at the notes that we have just taken